Hello world, Lisa Fredrickson, your friend and computer science professor here with a short screencast about Project 5 functions. I thought it might be good to just debrief on this and show you the solution through a YouTube that might help solidify these skills. All of this is really going to be important for you going forward, both for the midterm and also just your general JavaScript knowledge. So I thought that maybe just walking through these 10 different little exercises might be helpful to you. So I've copied and pasted all the exercises into my little code editor here. I'm using Notepad++ for this, and I've got all the solutions. First one people did pretty well with, and that is just to prompt for two pieces of information from the user, their age and a proceed variable, asking them if they want to continue. Now the prompt method collects whatever the user types into the prompt, whereas the confirm method only collects either true or false based on the little dialog box that's provided. And I console log out these issues to confirm that after I've collected that information. So let's go ahead and just comment out the rest of this code and just make sure that our variables are storing what we want them to store. So we'll go to my web page here and refresh, and it's prompting, what is your age from line 13? I'm going to put in 5. Do you want to continue? I'll put in OK, and that logs out 5 and true from the age and proceed variables. Now if I refresh this and put in 55 this time and say cancel, then I'm getting 55 and false. So I'm just proving to myself that the confirm method is going to return true or false, and the prompt method is going to return whatever I've typed into that dialog box. Now let's go into the if statement. And people did pretty well with this, but there is a tricky part. Then let's go into the if statement here, and we're testing if age is greater than or equal to 18, if proceed is equal to true. Now, the tricky part of this is sometimes people put proceed is assigned to true, and that is always going to end up being truthy or true, regardless of whether we clicked OK or cancel when we got that confirmation. So make sure that when you're comparing two values for equality, you use 2 or 3 equal signs. This will test whether proceed is equal to true in both value and in data type. If we're greater than or equal to 18 and we've clicked OK when we've asked whether we want to continue in the confirm dialog box, then we're going to prompt them for one more piece of information, their name. I'm going to go ahead and console log that out and then also run through this statement, which goes to the document, gets the element by ID, that is ID legal message, and I've got this little paragraph sitting up here, work on its text content property and assign it to the user variable plus the string is legal. Now, you did not have to put an else statement into your code to get this correct, but I went ahead and added that just so that regardless of whether this test evaluates true or false, we've got something on the page to confirm that. So let's save and let's refresh. What is your age? I'm going to put in 25. Do you want to continue? OK. And that's true and true. So I'm being prompted for my name, Lisa. And this statement here is being run. User, whatever I typed in the user variable, is legal. So that's true, true, and that makes all of this work. Now I'm going to retest for true and false. Do I want to continue? I'm going to say cancel. And I'm expecting the false part of branch to run, and it did because this is true, but this was false. Now let's do it the other way. How about 5, and do you want to continue? Okay. So now I'm false true, and I'm also expecting the false part of this branch to run. So that tested all 3 conditions, true, 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 false, and false, true. For number 2, you were to copy the check-in login code from the logical operators exercise and just modify the variable names and the strings to make sense for a 2-step process to identify a favorite sport and then a favorite team. So I've changed my variable names from the example to accommodate favorite sports instead of users and favorite teams instead of passwords. And I've also changed my alerts to console logs that are appropriate for the test. So the first test is to prompt for the favorite sport and to check if it's football. And in my prompt, notice that I have a second argument here, which just provides a default value. This makes it easier to test because the default value is already there and I can just click OK. So favorite sport is football. I'm going to do this section of code. I'm going to click OK. What is your favorite team? If my favorite sport is football, I'm going to prompt for my favorite team and provide a default value of Chiefs. And then I'm going to test if my favorite team is Chiefs, and I'm going to click OK and say it is. Then I'm console logging out Go Chiefs. Now, the rest of this is if I don't enter a favorite team, if it's an empty string or if it's null, then I didn't enter a favorite team. Or if I enter anything other than Chiefs, I'm going to console log out wrong team. So let's go ahead and test those. My favorite sport is football, but I'm not going to enter anything in for a favorite team. I'm going to get you didn't enter a favorite team. How about if I choose football but put in Vikings? Then I've got the wrong team. And of course, if I enter in anything other than football, if I enter in baseball, I'm getting this console log. And if I wipe it out altogether and do an empty string or a null, then I'm going to get this console log. You didn't enter in a favorite sport. I want to check all 5 of those console logs to make sure I want to follow this flow chart, but instead of using their example of who's there, I want to ask for the favorite sport and have an answer if they cancel, if they have a favorite sport other than football, and if they answer football, I want to have an answer if they cancel their favorite team, if they have the wrong team, or if they have the Chiefs. So we're following this flow chart. We're just providing different meaningful variable names and different console log statements that make sense in the context of this example. For number 3, you're to create a variable named secret and assign it to a number between 1 and 10. No problems there. Write a while loop that keeps prompting the user to enter a number between 1 and 10. Stop prompting the user once the secret number is guessed. The while loop puts the test up front. And so since it's going to go ahead and test whether secret is equal to guess, I'm going to assign both secret and guess to numbers that don't match, so that this prompt is going to keep running until they do match. So if secret is not equal to the guess, then we're going to reassign the guess variable to the prompt. Some of you put let in here, and that's going to cause a console error because let is only used once to define the variable. Once the variable is defined, then you can reassign it as many times as you want. But you only create it once with let. So this is just the simple part of this example to make sure that you knew that keeps running the whatever code you have inside this while loop, and I only have one statement as long as that test is true. So I'm going to test that right now by commenting everything else out and just focusing on that one little piece of code. I'm going to refresh, enter a new guess, because when it goes into the while loop, 2 is not equal to 0. I'll try 1. I got prompted again. If I try 2, then I quit getting prompted. And I added this console log at the end. Yes, you guessed the secret number of 2, just as a confirmation that the loop is finished. And number 4, you were to rewrite that loop, only this time using a do-while loop. The only difference between a while loop and a do-while loop is where the test is. So the do loop always runs the loop code once because the test is not until the end. So in this case, I set secret 2 and guess 2 to different numbers again, and I'm going to do guess 2 while they're not equal. So it's going to run through that code once. So in this case, I'm going to save and refresh and test this. What is your guess? And I'm going to guess 1. They are not equal. How about 2? They are not equal. 3. Finally, secret 2 is equal to guess 2 when I make guess 2 3, and then they're equal. As soon as they're the same number, this test is not true anymore, and the while loop stops. On number 5, we're to write a for loop. Console log numbers between 1 and 31 that are evenly divided by 3. So the for loop has 3 parts. We're going to start the counter at 1, we're going to end it at 31, and we're going to increment by 1. And our test is to console log out the number if it's evenly divisible by 3. To figure out the remainder of a value, you use this. So if 1 divided by 3 is equal to 0, I want to cancel out 1. It's not. How about 2? It's not. The remainder of 3 divided by 3 is equal to 0. So I expect my first console log to be 3 and then all the multiples of 3. So let's save and refresh our web page and see how that looks. And yes, we should be getting 3, 6, 9, all the multiples of 3 up to 30. To console log the numbers between 1 and 31 that are evenly divided by 3. Because this little symbol gives you the remainder and we're comparing it to 0. Those would be the numbers that are evenly divisible by 3. For number 6, we're creating a variable named house and we're assigning to the value of a prompt for the user's Hogwarts house. And in my case, I decided to just shorten this a little bit to the first letter. And so I'm going to let the user know that by entering a second argument in my prompt. I'll just say enter G, S, R, or H. And then we're going to use a switch construct to determine our next statement. So if the user enters G, I want to console out Gryffindor and then break out of the case. S for Slytherin, R for Ravenclaw, and H for Hufflepuff. Now sometimes you see these statements on multiple lines and that's fine. I just put this all on one line to save a little space here. But the point here is that every case, it's whatever house equals, goes down and looks at this case. Does the value of the house variable equal any of these cases? And if it does, it's going to run the statements that are inside that case. In the switch construct, you do need to include this break statement as the last statement for every case, because otherwise you get a feature called fall through that the subsequent case statements also run. So it's a little interesting about the switch statement. I'm also going to add a default value to the switch construct. No house exists with this first letter. And that's the case then that will run if I don't enter G, S, R, or H into this prompt, because house won't match any of these cases. Let's save that, and I've refreshed. And what is your house? Enter G, S, R, or H. If I enter G, then 2 statements are running. I'm console logging out Gryffindor, and I'm breaking out of the switch statement. Let's try it again for S, Slytherin, and I'm breaking. Let's try it one more time for anything else. How about P? There is no case for P. So when I click P, I get the default case, which console logs out the fact that no house exists with this first letter. It's really common to have a default case in your switch statement in case none of the prior cases do match. On number 7, we're simply doing the exact same logic, only with if and else if statements. And so again, we're prompting for the house. I've declared a new variable, house2. You could have used house without the let statement, but I personally wanted to keep every exercise contained with its own variables. So I just used house2, in this case, a new variable name, prompt what is your house? And again, I'm using just the first letter of the house to identify Gryffindor, Slytherin, Ravenclaw, and Hufflepuff. And I've used slightly different console logs. And here's my default. If none of these answers, G, S, R, or H, are given for house 2, then we're going to console out you're a muggle. Okay, save, refresh. Now, what is your house 2? I'm going to try the R, and I'm getting Go Gryffindor. And the reason I'm getting that is because I've used the assignment statement instead of the equality operator. So let's fix that right away. Save, refresh. What is your house? Let's try R again. Go Ravenclaw, good. H, go Hufflepuff. I would want to try all of my branches, but let's try L, and I am a muggle. So when you're doing an equality check, be sure you use 3 equal signs to check for both the value and the data type. On number 8, we're merely to wrap that code in a function named sorting hat as a function declaration. Here's how we declare a function with the function keyword. Here's our function name. We declare it with the function name followed by parentheses. If there are any parameters for that function, we enter those parameters inside the parentheses. In this case, there are not. And then we wrap all the code with curly braces. So we want to be real careful about our curly braces here that the switch statement has its own set of curly braces, and then the function has its own set of curly braces. And if I save and I refresh, nothing is happening now. And we know that that's one of the purposes of wrapping your code in a function so that you can control when it runs. Now we can run it here from the console by typing in the function name with parentheses, which says run that function. And we're being prompted, what is your house, GSR or H? I'm going to put in H, and I will then console log out Hufflepuff. Obviously, the developer tools are only for developing the code. You're going to want to reference that sorting hat function somewhere later in the code to run it when you desire. But right now, we're protecting that code so that it only runs when we run or execute the sorting hat function. Number 9 was the same thing, only with the if-else-if structure. We're surrounding that code with a function expression just to make sure that we're cool with both syntax structures. In function expression, the function goes in the place where you would normally see an expression. And where do you normally see an expression? After an equal sign, because you're assigning that variable name to this expression. When you do this in JavaScript, you run that function by using the variable name as if it were the function name. So both ways of creating a function are so common in JavaScript that I would not be doing you any favors if I didn't show you both ways of doing it. Personally, I think that when you use the function keyword before the function name, it's a little more obvious that you're creating a function than when you declare a variable and assign it to a function. But both methods are really common, and so you need to know both methods of creating a function. So that's all that step 9 asked you to do, was to wrap that existing code with a function expression, and that includes this line on line 15 and a final curly brace. And none of that code then, because it's protected by a function, runs. So now I'm refreshing my page and nothing is happening in the console, which is then demonstrated in step 10, where I ask you to run both the sorting hat and the sorting hat 2 functions. And for that, you had to know how to run a function, which is just a function name followed by parentheses. If it has arguments, you have to add the arguments. Neither of these functions had arguments. And also in a function expression, the variable name acts as if it's a function name. And you can run the function with parentheses the same way. So that was the answer to number 10. Both of those functions are now going to run when I refresh the page. Here's my sorting hat function. I'm going to put in G, Gryffindor, and here's my sorting hat 2 function. I'm going to put in R and go Ravenclaw. If you have any questions at all, you know what to do. Thank you.